Anand sir and our principal Dr. R.M.
Dr. K.M. Satish Kumar, Professor and Head, Department of Mechanical Engineering, BMS Institute of Technology and Management, Bengaluru, who is going to talk to us about the introduction to diagnostic maintenance. Sir has 22 years of teaching experience and 10 years of research experience. Sir authored a textbook titled Computer Integrated Manufacturing. And Sir research area is on condition monitoring. Sir guided 1 PhD and at present Sir is guiding 3 PhD candidates. Sir has published more than 13 international journals and 16 international conferences, 12 national conferences. With all this, I request Dr. K.M. Satish Kumar sir to share his knowledge on diagnostic maintenance. Over to you, sir. Sir, your voice is not audible, sir.
Yeah, now?
Yes,
yeah.
Sir.
Yeah, thank you. Thank you, Dr. Gurupavan, for a brief introduction. And I take this opportunity to thank all the authorities of the PS College of Engineering, Mandya. So my alma mater, okay, was given this opportunity to deliver this lecture. Thanks to Dr. Dinesh Prabhu, sir, also. And with the brief note, with your all permission, I think I'll start my presentation. Can somebody confirm, please? Hello?
Yes, sir.
Yeah. Is the screen visible, sir?
Yes, sir.
Yeah. Shall I go ahead?
Yes, sir.
Yeah. Okay. Thank you. Thank you, Pawan. Right. Yeah. Good morning, dear audience of this FDP program on the diagnostic maintenance of mechanical system. So I will be the speaker who is talking on introduction to diagnostic maintenance. So as the speaker of the first session, I thought to take this as the agenda of my presentation, wherein I will be covering broadly about the concept of diagnostic maintenance, why it is required, what are the different means with which we could able to do the diagnostic maintenance, the different techniques, and ultimately we'll be finally concluding with the importance of diagnostic maintenance. Specifically, I have put the talk something like this. Most likely, it is going to be on the introductory concept of the diagnostic maintenance, which covers the various different techniques of the diagnostic maintenance. Maybe on the subsequent days, you will be going through, as I have gone through with the schedule, you will be going through with the individual diagnostic maintenance techniques in detail. So with this, so we'll start the presentation. So myself, Dr. Satish Kumar, Professor and HOD, Department of Mechanical Engineering, BMS Institute of Technology and Management, giving this talk for the day today. Right. Now, the agenda of the presentation is, we'll be looking at the introduction about the diagnostic maintenance, what exactly is the goal, the various different methods of diagnostic maintenance, the techniques which covers the diagnostic maintenance, and with the advent of the industry 4.0 present in the picture now, how this industry 4.0 is going to help to improvise the diagnostic maintenance, and we'll have a concluding remarks. So this is the flow of the presentation. So let me just start with the basic introduction of the diagnostic maintenance. So as we know, basically the very basic concept of a maintenance is to make sure that the facility is available to you at all the time during the production. Mainly when I am going to talk about the facility most likely is with respect to the equipment, with respect to the people, and with respect to the cutting tools which are present in the production system. When we are going to calculate all the efficiencies, might be the production capacity, efficiency, utilization, and all. So what matters is, what is the level of availability of the machines which are that ready to use. So in order to give this a basic idea, so the department which is supposed to take care is what is called as the maintenance department. So what is that we need to, the major requirement is to make sure that the machines are going to be available at all the time. So this is the basic fundamental of what is called as a maintenance. So when we talk about maintenance, there are different types of maintenance which are going to be there. So which are called as your breakdown maintenance, preventive maintenance, predictive maintenance, the condition-based maintenance. There are plenty of maintenance which are present. So now as of now, we'll be concentrating on what is called as a diagnostic maintenance. So basically, a diagnostic maintenance, as it is given, it's nothing but a strategy wherein you are checking or you are monitoring, okay, the actual condition of an asset to decide what maintenance needs to be done. Now here, when we are talking about the asset is nothing but the machineries which are present in the facilities, okay, which are maybe the various different types of the machines which are going to be present. Now you are going to continuously monitor. Now the monitoring is going to be done with respect to what is very important. Basically, in case of a diagnostic maintenance, we are diagnostic. Okay, we are going to diagnose. Okay, basically, as like we go for a diagnosis laboratory, wherein they are going to check the vital parameters of our body, and by observing the vital parameters of our body, so they are going to say, so this is what is the situation which might come into the picture in the next days. It is just similar to that. It's just similar to that. So the body here is nothing but the machineries. We are going to have a data about the machineries. By doing what? By placing the various different sensors at different locations, at the salient location by which I can able to pick the information. So the basic understanding is to develop a strategy. Okay, develop a strategy which monitors the condition of a machine tools or the machine for that matter, right? So basically, now by observing the data that we are going to gather, that is very important here. So we are going to get some signs of the significant changes, okay, which are going to occur, which might give a certain problems when you continue with the same procedure or the same way. Okay, now the data what you have gathered will tell something about the happenings which are going to be definitely going to happen on that machine after some time now, right? Now then what might be the basic goal of our the diagnostic maintenance? Now basically the goal is to monitor and spot upcoming maintenance equipment failure. So that is what is very, very important. So we are going to proactively schedule when exactly the maintenance strategy has to be made and not before. Now what's going to happen if it is going to be a breakdown maintenance, let us say. If it is a breakdown maintenance, you let the breakdown to occur. It's very simple technique. You let the breakdown to occur. Once the breakdown has occurred, then you are going to do the analysis and then do the rest of the activity. If it is going to be a preventive maintenance, now every now and then you plan your activity. Every now and then you make the activity, you make what is called as your the plan to occur, something like that. That means in case of your what is called as your in case of what is called as is it disturbance? Okay, right. So in case of what is called as your as I said, the preventive maintenance, so there is going to be a fixed schedule of maintenance which are going to be present. So whether it is going to be required or not, at those fixed schedule you are going to check the machineries. But in case of a diagnostic maintenance, it is the process wherein you are checking the health of the machineries continuously and take a assessment when it is needed and not before. That is very, very important. Okay, right. And by doing this diagnostic maintenance, basically it improves equipment's the performance, okay, with respect to the availability. Maybe the commercial availability means if it is going to be available more, we will be getting more profits than engineering and the environmental performance. And it ensures operational longevity of the equipment that is much required. Basically, if the machines are going to be available for a longer duration of time, then it is ensured that you could able to produce some component out of it. Okay. Then monitoring allows diagnostic and performance analysis. Then benchmarking allows assessment of change in equipment, performance and condition. And here monitoring, benchmarking and prediction of failure. So these are the the main the goal of the diagnostic maintenance which are going to be present, right? With this brief the goal and the thing, we'll just move on to what is called as the methods. Basically, when you go with the methods of diagnostic maintenance, so we have two different diagnostic maintenance methods which are present. One is called as the trend monitoring, other is called as the condition checking, right? Now we shall just go on understanding one by one. Okay, so is my voice clear, sir? Please can confirm. Am I audible?
Yes, sir.
Yeah. So trend monitoring. So basically, the concept of trend monitoring is the continuous, regular measurement and interpretation of the data. Now, in this trend monitoring, you will continuously measure the data, continuously measure what is the changes happening, and it's a regular measurement, and you are going to interpret the data based on the data, the continuous data that you are going to check. Okay. So basically, it's also going to be called as the continuous monitoring. It's also going to be called as the continuous monitoring. Now, here in trend monitoring, as the word says, you are picking the word called as the trend here. Okay. Now, the trend, you are trying to understand, or you are trying to study the trend of the parameters that you are looking at. Okay. Now, the parameters might be anything. The parameters might be a vibration parameters. The parameters might be an acoustic emission parameter. The parameter might be a temperature, or the parameter may be a contaminant samples, or the contaminant product that you have done in the oil samples. Okay. Now, those trends you are going to study means by analyzing the trend, you could able to come across with a clear understanding that when there might be a possibility of this trend goes out of the limit. When the trend goes out of the limit, then you can able to assess if I am going to continue this process in this particular manner, definitely by another next shift, there might be a critical problem which might be occurring in this machine. So hence it is required for me to take some corrective measures. Okay, now you are going to follow what is called as the trend there. Okay, so that is called as the concept of a trend monitoring. Okay, you pick up some suitable and measurable parameters and go on observing those parameters whether it is present within the limit or not. Okay, right. Then the second one is going to be called as the condition checking. Okay, so second parameter or the second type is going to be called as the condition checking, where the condition checking involves taking a periodic check measurement with an appropriate indicator while a machine is running. Okay, now this is very, very important. Now, this is what is going to be largely going to be used by in the industry, wherein you are going to continuously check. You are going to go with a periodic check measurement with an appropriate indicator while the machine is running. Now, basically, the information from this method is then used to measure the condition of the machine at a given time. That means once you are going to take the note of the values that you have got, okay, once you may take the note of the values that you have got, then based on those values, you are going to check or you are going to measure the condition of the machine at a given point of time. So basically, this condition checking is going to involve broadly the three different steps. Okay. So basically, it is the detection. Okay. So it is the things are going to be, it is detection and yeah. Okay. It's first one is detection. Now, basically, when I'm going to say about detection, it says about when aspects. That means it involves the identification. Okay, basically the detection involves identification of the developing fault at an early stage. Okay, it tries to detect. Then once the detection has been made, once some problem has been detected, then you go with what is called as diagnosing that. Okay, first is when, and then what is that you are going to do with that particular detection that you have made. Okay, that means now during the diagnosis stage of the condition checking, it involves identification of the origin of this particular problem, okay, so that you could able to address that properly. Okay, so the third one is going to be called as the prognosis, okay, which is called as the forecasting. Okay, the prognosis is nothing but the forecasting. So basically the forecasting or the prognosis tells about the how to establish the trend, okay, in the next stages. That means if this is going to be the parameters that you are going to take in the next stages, what is the possible problems which are going to occur. That means detection, diagnosis and prognosis is what you are going to do in case of what is called as a condition checking. Now, before you could able to get the major changes in the vital parameters, you should take a call. Okay, so that is going to be the basic aspect of what is called as the condition checking, right? Then when it comes to the different types of the condition monitoring, so basically we have the offline condition monitoring method and the online condition monitoring method. Okay, so basically what's going to happen is, so if it is going to be an offline condition monitoring, so it is going to be generally, okay, the work is going to be it says offline, wherein you are going to stop the machine and you are going to take the vital parameters. Okay, so it is not advisable on any industrial in an industrial environment to stop the machine for doing some of this type of the activities. So generally this offline condition monitoring is used for less critical or semi-critical assets, okay, which are not much of the problem, whereas the periodic scanning is good enough to observe the current condition. But largely what we use is what is called as the online condition monitoring. Okay, so as I said, now in the case of online condition monitoring, what is very important that we need to know is the importance of what is called as a sensors. Okay, now here the role of the sensors is going to play a major role in the online condition monitoring, wherein you are going to wirelessly connect, okay, the machine mounted sensor to the software. So you will be having a sensors mounted on the housing of a bearing, okay, sensors mounted on the headstock, sensors mounted on the beneath the tool. Okay, so some you might be using some infrared gun which is pointing towards the cutting tool to measure the temperature. So these are all the sensors which are going to be present, which are generally the machine mounted sensors. Okay, now what else that we are going to do is, from this machine mounted sensor, we'll try to take the information to the various different the softwares which are going to be available, okay, which are going to be the diagnostic softwares which are going to be available to know the real-time happening in the shop floor. Okay, therefore it is very clear to state that, so what is happening, you are going to see. Okay, it is just simple that, so there is something happening in the factory, so you are, as it is sitting in your the office, and you are analyzing what is exactly is happening. Okay, it is not it's going to be that much level of a clarity with the operation which you are going to get. Okay, now because of nowadays what has happened, as you have observed, because of the amount of improvisation, okay, in the sensor technology, it is possible for you to have a customizable the sensors which is going to be used for your requirement. Okay, right. And another very important thing is now to spot to fix the sensors in a correct way, so that it is wirelessly connected to a remote condition monitoring system. That is very important. You need not to sit there in front of the system or in front of the machine to see the activity. So you can remotely connect the readings to the systems which are at the office environment, and you can sit at the office environment and you can observe the real-time variation of the data. Okay, so that is the beauty of online condition monitoring. Okay, now as I am continuing with that, so it's also possible for you to integrate the multiple sensors. So that is a multi-sensory approach. Okay, so this is very important, wherein for an impending failure to occur, please understand that it is not only the vibration matter, it is not only the acoustic signals matter, it is not only the temperature matters, it is not only the ultraviolet rays matters. Maybe the failures can be detected through the various different parameters. Hence, it could be possible for me to take the vibration data or the thermography data, means the temperature data, or what is called as the acoustic data at a given time. Okay. So now in this case, when you are going to take the data, it is possible for you to alert. It's very important that it's possible for you to give a real-time alerts to various different peoples who are present with these activities. Okay, right. So with the understanding of offline and online monitoring, so now basically what we are looking at is only the online monitoring, where we are going to extract the data from the multiple sensors and will analyze those data in the various different diagnostic maintenance software, and based on the data that we are going to analyze, we are going to say what action needs to be taken if there is going to be changes in the critical parameters. Okay, so that is basically right. Then we'll just try to understand something called as the PF curve. Okay, right. So basically, this PF curve is going to say about it's a time on the x-axis basically, and on the y-axis we will be having the condition of the asset, or the health of the machines for that matter. Okay, so with the variation in the time, how the health of the machine is going to vary, so that's going to be your the PF curve. So basically, over a period of time, I'm trying to say about the interval between the potential failure and functional failure. Okay, so P is the potential failure, F is the functional failure. Okay, so basically the potential failure to be considered as, it's going to be defined as, it is a starting point at which the machine starts to deteriorate. Okay, so it is the point where there is a problem started to begin. Okay, then a functional failure is a point wherein it has reached the point wherein after that it is not possible for it to function anymore. That means it is the last stage of the operationality of the machine. So potential failure is the first stage of the problem beginning, and the functional failure is the dead state. Okay, now this is what is called as a PF curve. This is something like this, right? So this is where the problem started. Okay, potential failure, the problem has started, and as and when you know that it is a basic understanding that as and when the time processes, the health of the machinery starts to reduce, and at certain point of time, there is going to be a functional failure occur. Okay, that means functional failure is later this point, the machine is not available, the machine is not functional. That's it. Okay, so now this time, the time interval between your potential failure and what is called as your the functional failure is what is called as your PF interval. Okay, now as a diagnostic maintenance engineer, okay, now what is our job is, okay, to make sure that you need to have a diagnosis well before this PF interval, right? Correct? Because so this is where the problem started to occur, then this is where the problem end. Okay, the problem has reached the maximum stage. So when you are going to have a plan, make sure that the maintenance activity should be lesser than the PF interval. Okay, if it is going to be after the PF interval, it means that you have taken the diagnosis option once the machine has failed, which doesn't make any sense at all. So therefore, and the effect of that, the effect of diagnostic maintenance is to do what? Is to make sure to increase this PF interval as long as possible. That means now if I am going to do this, now if I am going to make the diagnosis, so it should go something like this. Okay, so probably, okay, just a picture. So now this is going to be my point of failure. Let's say that now I could able to increase from this point to this point. I have elongated, I have improved, we have improved the life of the machine to this extent by having a proper diagnostic operation or the proper diagnostic maintenance. So that is what is called as the PF interval talking about. That means the condition monitoring plays a significant role in detecting the PF interval of the PF curve. So as I said, so PF interval is the time between an asset's potential failure and its functional predicted failure. Okay, now what is required is the inspection interval should be smaller than the PF curve. Okay, now the inspection, what is that you are going to do? It should be smaller than the PF curve, and it should should end up in maximizing the PF interval. So this is what is very, very important. Okay, the ultimate objective of the diagnostic maintenance is to increase the PF interval. Okay, so this is about the concept of PF interval. So now with this, the basic idea about the introduction to the diagnostic maintenance, okay, and understanding about the types, right, and the methods, and that is offline and online monitoring, and about the PF curve. Then we'll just switch over to what are the various different diagnostic maintenance techniques which are available. Okay. Now, I will be briefly touching upon what are all the various techniques which are going to be there. Maybe later in the sessions, you will be having a session exclusively on these individual techniques. Okay, as the first session, I just thought to have a brief idea about all this. Okay, now when you go with the diagnostic maintenance techniques, I just listed the commonly used visual inspection, right, and then the vibration monitoring, the AE monitoring, acoustic emission monitoring, the oil analysis, infrared thermography, ultrasound testing, and remote visual inspection. So these are the commonly used techniques. Let us just have a look at the individual, what exactly is all they about. Okay, right. Now, visual inspection. Now it's pretty clear. It's pretty clear. So what is visual inspection? Okay, seeing is believing. Okay, I'm going to observe and I'm going to make a note of it and I'm going to make a decision. As simple as that. Now, in case of visual inspection, so basically it's an inspection of an asset made using the naked eyes. You just observe. Okay. Now, while moving in the shop floor, you keep on observing what is exactly is the changes which are present on the machine. Okay. Now, even though we are going to say it's just an observation, it's an observation. So it is very much required. Okay, it is very much required to have a specific training. Okay, so that at least the inspector should know what to observe. That is very important. Okay, it is just the observation doesn't make any sense. Now, what is that you need to observe is what matters in the visual inspection. Otherwise, this visual inspection is just like a tour. Okay, so nothing is going to come out with that. Now, what to observe is what is very matters, right? And it is as you know, it is the very oldest one, okay, to evaluate the condition of an asset. Okay. Now here the goal is to find anything that might be wrong with the asset which could require maintenance. Okay. Now it is not specific to any particular aspect of the parameter. It is on the overall front of the machine. You just look at the machines and understand what might be the problem. But generally, this visual inspection cannot be considered as an authenticated one. Okay, or you can't rely completely on the visual inspection, because there are impending failures which are going to happen because of the parameters which are happening within the system. Okay, so anything which is outside the system you could able to observe and gauge, but some changes happening within the body, so which it is highly impossible for an inspector to look at. Okay, therefore, then comes the various different types of the monitoring systems. Okay, now those monitoring systems will require what is called as a sensors. Okay, sensory data. Okay, so in order to pick the changes in the parameters. Okay, right. Now for that we have the various different techniques now. Then we have what is called the second one. We have what is called as the vibration monitoring. Okay, now largely the majority of the machines, okay, majority of the machines are going to be with this particular aspect. Okay, now the failure is going to be due to the vibration aspects of the machines. Okay, so if you understand about the total failure statistics of a particular machines, the machines will generally fail due to the vibration aspects. Okay, now the basic understanding of the vibration, it's a physical movement or oscillation of a mechanical part about a reference position. From a reference position, it starts to move to and fro. Okay, so we call it as a vibration. Then, for that matter, everything, every creature on the earth is going to vibrate. Okay, just like anything, the machines will also going to vibrate. Now the question is, the vibration is going to be the part and parcel of the story, but what is the amount of vibration which could be acceptable is what is that we need to take care as a maintenance engineer. Okay, now the signature, we call it as a signature. Signature is nothing but the undulations, or signature is nothing but the variations in the parameters due to this vibration aspect. Okay. Now, definitely this vibration analysis can help to detect a wide variety of the fault conditions, right? Then it's an important indicator of the mechanical integrity of the rotating machine. So basically, it's going to be applicable to the rotating equipment. Okay. So vibration within the rotating machinery tells a great deal about the condition of that particular machine, and detailed vibration analysis can reveal far more information. Okay. So broadly, we can define the vibration analysis as a process for measuring the vibration levels and frequencies of the machinery, and then using that information to analyze how healthy the machines and their components are. Now, it says it's the process of measuring the vibration levels. Now, as per our International Organization for Standardization 10816, okay, so ISO 10816 says about what are the various vibration levels which are acceptable depending upon the type of the machines. Okay, depending upon type of the machine, so we can able to have a clear-cut data about the amount of vibration levels which are acceptable and which are not acceptable. Okay. Now, by having an accelerometer, by having a vibrometers, okay, so we can able to pick the vibration signal from the rotating machineries, and we can able to analyze. Okay, now in order to do this operation, okay, so before that we'll try to understand what are the different defects which could be detected through the vibration analysis. Okay, now so during the machineries we will be having the various different defects which are going to be there. So which are the one which could be largely detected from the vibration analysis? So basically the first one, and a very important one, is going to be called as your unbalance, or you can also spell it as imbalance. Okay. So basically the unbalance is going to be the most large the machinery defects which could be detected through the vibration analysis. Okay. So unbalance is because the vibration is going to be for a rotary machinery. Any rotating member might come across with this concept of what is called as an unbalance. Okay. So this unbalance is going to be created when the center of the mass differ from the center of the rotation. Okay, that is F is equal to mr into omega. F is equal to mr into omega square. Okay, basically, whenever there is going to be a difference, okay, difference in the rotation axis, then creates what is called as a centrifugal force. Okay. This centrifugal force will try to take the body in the outward way. Okay, when it is going to take the body in an outward way, it gives rise to what are called as the high vibration amplitude. Okay. Now, basically, this is we can simply say this is an uneven distribution of the mass. Okay. So the unbalance is going to be results due to the uneven distribution of the mass about a rotor's rotating. Okay. Now, basically, if the centrifugal force is going to be large, that distance is going to be large, that is eccentricity is going to be larger, there will be more amount of centrifugal force which tries to take the body in an abnormal way, which gives rise to a larger amount of vibration, and this will assimilate. Okay, this will assimilate to the other problems like the looseness, like the bent shaft. All those things will start to prolong. That is, a single unbalance will give rise to the other different aspects of the defects. Therefore, so this has to be taken care very effectively during the machinery analysis. Okay, right. The next one is going to be the misalignment. Basically, this misalignment can result when the machine shafts are out of line. Okay, that means the two shafts you're connected with a coupling, let's say, and when they are going to rotate, now there might be a possibility of the misalignment with the axis of rotation. So accordingly, we have two different types of misalignment. Okay, broadly, the angular misalignment, okay, whenever the axes of the two shafts are not parallel and they are going to meet at a particular angle, there is some angularity between the axis of the shaft. So it's an angular misalignment. Then parallel misalignment, when the axes are parallel, the axis of both the shafts are parallel, but they are not in line. Okay, so they are out of line by a small variation. Okay, that is called as your what is called the parallel misalignment. Okay. Then the combined misalignment, it is having both. Now, just a simple figure to analyze the concept of the alignment. So this is what is that the center line of one shaft is exactly in line with the center line of the other shaft. It is an expected deviation. Okay, but now with the unbalance or with the other issues or with the temperature changes, there might be a shift. Now here the shift is happening in a common way, wherein the center line of one shaft is not in line with the center line of the other. So this is going to be the gap which is going to be there. So when both of them are going to rotate, they will not rotate in an evenly manner. That's called as the parallel misalignment. Then we have the angular misalignment. The axis of the one shaft is making an inclination with the axis of the another shaft, which is called as an angular misalignment. And the combined one is the combination of both parallel and angular misalignment. Okay, now this is the second. Then the third one is going to be the looseness. Okay, so basically this mechanical looseness is going to occur when the rotating component have fitted incorrectly. Okay, when it has been fitted incorrectly, now might be the bearings fitted onto the base. Okay, so that might be a problem. Okay, now this looseness will have not a stable base, right? So the looseness will not going to have a stable base. So by which whenever there is going to be a rotation or the failure is going to occur, so these problems are going to, the vibration problem starts to come into picture. Okay, now other than this unbalance, misalignment, and the looseness, there are other the defects also, which could be a common faults in the rotating machinery. They are going to be eccentricity. Okay, right? There might be a air problem, or there might be a whirl problem. Oil whirl problem is going to be present. So eccentricity is another the problem. Okay, now in the machineries which are going to occur. Okay, now generally, more largely, this unbalance, misalignment, and looseness are the ones which gives more amount of the vibrations to the sensor. Right. Then what are the parameters defining vibration signal? So this is going with only the basic introductory aspect of this the concepts, right? So parameters which define the vibration signals are the amplitude, okay, which is the size of the vibration signal, and it says about the severity of the fault. As you know, higher the amplitude, higher the vibration, right? And then we have one more thing called as the frequency, okay, that is 1 over the reciprocal of the time. So frequency is the number of times an event occurs in a given time. So this particular one event is going to be called as a one vibration cycle. So in this one vibration cycle, there is going to be some peaks are going to be present. Okay, so those peaks are called as the frequency points. Okay, that means it might be, the peaks might be at 1x, peak might be at the 2x, means at the harmonic level or at the subharmonics level. So what we need to understand is, if the peaks are coming exactly at an interval of time, okay, exactly at an interval of time, then it is due to a particular defect. Now, if the frequencies are going to be at a subharmonic style, that means at 1x, 2x, 3x, 4x, or something like that, the types of the parts are going to be at a particular time. That means, now this point is very important. The types of fits, the types of faults typically occur at certain frequencies. Okay, now at certain frequencies, let's say if 1200 RPM is going to be, let's say 1200 RPM is my speed of the rotor. Okay, right. So if it is the case, so 1200 RPM divided by 20 divided by 60, it's going to become your 20 hertz. So 20 hertz is going to be the frequency. So if it is going to be 40 hertz is the vibration, it means 2x. 1x is 20 hertz, 2x is like your 40 hertz, and 60 hertz is going to be your 3x. That means the vibrations, the peaks may be something like this. Okay, this is one peak, and this is going to be another, this is going to be another. So this might be the frequency at 20 hertz, maybe at 40 hertz, maybe at 60 hertz. Now these peaks will speak something, okay, related to the type of the defect which are going to be present. Okay, right. So that is what is about the frequency. Other is nothing but the phase, which is something related to the angularity concept, which measures the angular difference between a known mark on a rotating shaft and the shaft vibration signal. That is It might be in phase or it might be out of phase. Right. Then what are the characteristics of vibration that you are going to go with? Okay, the characteristics of vibrations are displacement, velocity, and so these are the simple terms. So the displacement is something when it is from a particular mean position, how much it has deviated. It is called as your displacement. The first derivative is going to be the velocity, and the second derivative is going to be called as the acceleration. Okay, now you could able to measure the displacement, velocity, and the acceleration. Right. Then when it comes to the analysis analysis technique, we have time domain analysis and we have frequency domain analysis. So basically, in case of a time domain analysis, it is the plot made with respect to amplitude versus the time. So amplitude is nothing but the vibration that you are going to get from the sensor. So that you place it on the oscilloscope, you are going to get the waveform. So on the oscilloscope, we get the waveform, and that particular waveform, if you are going to analyze, that is going to be in the time domain. So which is amplitude plotted against the time. By using your the FFT fast Fourier transformation, you could able to convert the time domain into the frequency domain. So in case of frequency domain, it is the frequency versus the amplitude. Okay, so on the x-axis you have frequency, and on the y-axis you have amplitude. Okay, so time domain is converted into the frequency domain. Okay, now analysis could be done by using time domain also, or could be done by using what is called as a frequency domain option also. So this is the general thing, right? Then the different equipment, okay, which should able to the vibrometers, okay. Handled vibrometers are going to be present. Okay, so this can be the handled instruments. The something is going to go from here onto the machine, which is being placed on the machine mountings. So the data you can able to get. Now this is going to be the signals you could able to observe on the monitor itself. That is, the spikes are going to be your frequency plots. Okay, you can able to observe the larger amount of the frequencies, which is going to say about the health of the machineries. Okay, now with the usage I have here. So now if you observe, this is going to be your sensor which has been mounted on the motor. Okay, on the housing of the motor. Then you have a handled vibrometers. Okay, so which you could able to measure. So measure with respect to any different domain. Okay, maybe a frequency domain or a time domain, or you could fix up the displacement, velocity, or the acceleration. Okay, now these are all the practices that one could able to make with respect to the concept of the vibration monitoring. Okay, now this is broadly about the concept of vibration monitoring, wherein you will be having an accelerometers which are going to be placed on the housing. Okay, and you could able to get the readings. Basically, this placement of the accelerometer itself is going to be a very important aspect. Okay, now whenever you are going to place the accelerometer, so the direction that the direction at which you are going to take the data is very, very important. Okay, now the vibration may be an axial vibration, the vibration may be a radial vibration, or the vibration might be the combination of both axial and radial. Okay, now the type of the failures, okay, that you are going to pick up, okay, is going to be very, very important. Okay, so accordingly you are going to place the accelerometer at a particular location, so that you take the maximum information. Because just observe, let us observe that you are placed on the vertical housing of your rotor. Okay, now assume that there is going to be larger of the horizontal vibration is going to be there, which may not going to pick up the horizontal vibration, and that horizontal vibration is going to be missed out. Okay, so therefore it is better to have the information from all the sources, so that you can make a good amount of the decision. So this is something called as the related to the concept of the vibration monitoring. Okay, then the second one we have what is called as the acoustic emission monitoring, so which is called as AE. Okay, it is basically acoustic is nothing but a sound. Okay, so it's an emission, a sound emission. Let us put like this. Okay, so now what is this basically? Okay, so basically it says that whenever there is going to be a defect present within the material, just we'll go like this. Okay, whenever there is going to be a defect in the material, which is going to be considered as a localized is something but a particular point. Okay, a localized defect. Okay, so which has not been spread across. Okay, maybe a mark, okay, might be a pitting defect, or might be a fatigue wear, or might be a crack present in the system. Those are called as the localized the defects which are present. Okay. Now, in case of acoustic emission, it's a phenomenon where the transient elastic waves are generated by the rapid release of energy from a localized sources within the material. That means whenever there is going to be a sensor you are going to place, and the acoustic transient is as it changes with respect to the time. So transient elastic waves are going to be generated with a larger amount of release of energy from the localized defect. That means wherever the defects are going to be present, we could able to observe a larger gathering of a data which is in the form of the energy. So that is acoustic energies are going to be present, and that acoustic energy which is going to be developed at a particular localized points are the point of concern that you are going to pick up by using by placing a acoustic emission sensor on an important locations. Right now, then we have the most of the sources of AE are damage related. That means there is nothing but the localized damage that I was telling. Thus, the detection and monitoring of these emissions are commonly used to predict material failure. Right? Just observe, the energy travels in a spherical wavefront and can be picked from the surface of the material using highly sensitive transducers. Okay, now this is very important. Okay, so acoustic emission sensors, okay, the placement of the acoustic emission sensor matters a lot, because the defect is going to be somewhere else, and if the acoustic emission sensor is going to be placed at a certain location, what might happen is the time with which it flows from the defect to the sensor area, by which there will be a diminishing of the reduction of the wavefront which are going to occur, and the data what you are going to gather will not be a effective data. Okay, therefore wherever the defects are going to be present, so the point of the AE sensor should be present there. Then this is what is the case here. So the mechanical wave thus picked up is converted into electrical signal, which on suitable processing analysis can reveal valuable information. Now you can observe here. So this is just a body we can observe. Okay, so you're having a sensor, then that is going to be what is called as a localized defect which is going to be present here. Okay, so because of that, because of the defect present there, the transient elastic waves are going to be generated and it tries to move around. Okay, that transient elastic waves, okay, are going to be picked up by this sensor, and that is going to be taken to the AE instruments. Okay, right. Now these are all the type of signals which are going to be present by using your the acoustic emission. One is called as your the burst emission signal, and the other is called as the continuous emission signals. Okay, so burst emission. Okay, burst emission is nothing but high amplitude, low frequency. Okay, so the amplitudes are going to be very larger and the frequency is smaller. That means you can observe the frequency of appearance is going to be smaller and the amplitudes are going to be larger. But in case of continuous emission, it's a lower amplitude. You can observe lower amplitude compared with the larger amplitude, and it is going to be a high frequency signals, right? Then there are very important parameters which are going to be there. So this is the one which is very important, because there are plenty of parameters which are present with respect to the acoustic emission signal. So accordingly, I have just listed some of the very useful parameters which are required to say about the machine. Okay, one is called as the threshold, the first one. Threshold is nothing but it's a voltage level. Basically, a threshold is a preset voltage level that has to be exceeded by the response so that it could be detected as an AE signal. Okay, now threshold is nothing but a voltage which should be discarded. Why you need to discard is very important. Okay, threshold is something, let's say that some machine is running, exactly, just assume a situation where the machine is running and there are some undue noise also going to be present on the side of the machine. Okay, the noise also has been incorporated into the system. Now if you are going to pick up the signal, you are picking the vibration of the machine along with the external noise. Okay, so that will gives you a increased vibration. Is it clear? So that is going to give you the increased vibration. So vibration within the machine plus vibration results due to the noise present outside. So in order to get the exact data, what I need to do is I want to pick only the data which happening within the machine. Okay. Therefore, I will keep a threshold. Okay. So threshold voltage. So I will calculate the noise which is present around the machine, and I will set the voltage for that noise, and any data which comes above that noise is going to be considered for analysis. That is called as a threshold. That means if you keep a very high threshold value, it means that you are missing many information. So if you keep a very less threshold also, you are incorporating all the noise. Therefore, setting a threshold itself is going to be a greater challenge in case of the acoustic emission monitoring. Okay, right. Then we have what is called as a count. Count is the number of times the signal amplitude exceeds the preset threshold. Okay, now, if I am going to keep a threshold, okay, just an observation. Okay, so right. So this is going to be your AE signal. So I have kept the threshold like this. So this is my threshold. Okay. Anything which is above the threshold is considered for analysis. Okay. So anything which is below threshold is because of the external noise. That is what is my observation. Okay. So my observation states that anything below the threshold is an external noise. So by observing the external noise, okay, which is happening, I have set the threshold. Okay. Now the count is the number of activities, okay, number of signals which we have got after the threshold. That means if you just observe, so this is the point at which the threshold is going to start. So that is why I have started the count here. So this is the end point. So that means how many number of count? Count is just the number. Okay, right. Then next is the rise time. Rise time is it is the time taken to reach peak amplitude from the first preset threshold voltage. Okay. So how much time? So now this is the threshold. This is the starting point. Please observe. So this is the starting point. Okay. Now, so this is not required for me. This is not required for me. This is not required for me. So this is the starting point. From here, I will elapse certain amount of time till I am going to reach what? Till I am going to reach the max. So this is my max. Okay. So the max amplitude. Okay. Now, what is the time taken to take from the initiation of the signal till the maximum amplitude? That is called as what is called as the rise time. Okay, right. So that's about the rise time. So peak amplitude, it is the single value. It is the highest amplitude reached by the AE signal during an event. It is measured in decibels. Okay, right. Then this is nothing but your this value is nothing but your peak amplitude. Then we have the RMS, which is called as the root mean square, which is a measure of the continuously varying AE signal voltage into the AE system. It's the measure of signal intensity. Then energy, it is a derivative. Okay, it's a derivative from the integral of the voltage level over a duration of the event and the signal strength. So both these are going to be the derivatives from the signals what you are obtained. So this is the equation that you are going to get. Now in your software, okay, so once you are going to make up, you are going to get all these data. Okay, so you will be getting all these data which are going to be present, and it is as a diagnostic maintenance engineer, we need to pick the right parameter which is required to analyze. Okay, now you pick the right parameters, and by plotting the graphs, okay, you could able to make what exactly is the problem. Right. Now, what are the AE system consists of? What exactly is required to make up an AE monitoring system? Okay, basically, a typical acoustic emission system consists of which are sensors which are used to detect the AE events. Okay, AE sensors are going to be required. Then we require pre-amplifier in order to amplify the initial signal. Okay, and then cables which should run from the sensor point onto your the software related issue. That means the basic observatory data, and then data acquisition devices that performs your ARD converters, okay, and filtration to take out the noise, okay, and the evaluation and data analysis. Okay, now this portion is very important, wherein you are going to do the evaluation, analysis, and the charting. Okay, all these are going to be the part of your the analysis software. Okay, now you took the data. That is one thing. One thing is that you took the data from the sensor. You have placed the AE sensor on exactly on the required position. you could able to get the data. And please mind, there is a very huge amount of the data which is going to be gettable by using your AE system. So with that huge amount of data, what is that matters you? Okay, that picking up of the right data itself is going to be a greater thing in case of the monitoring of AE, and subsequently after gathering, then how you could able to evaluate and how you could able to put across onto a chart so that you can able to present it well to the required members is what is matters. Hence, along with the sensor, along with the acquisition of the data, what also matters is how are you going to post process that data effectively is also going to be important. Okay, so these are all the AE. This covers a proper AE system, right? Then the application point of view, okay, it's a good application area for the AE monitoring, basically detection of the active sources, that means detection of the defects. Okay, now crack propagation can be detected, the fatigue, the creep, fiber delamination, fiber fracture, and corrosion. All this is happening on the subsurface level. On the subsurface level, all these happenings are occurring. So that can be taken by observing the waves. Okay, structural integrity can be evaluated, weld quality can be checked. Okay, so quality control, leak detection, all this, and a general laboratory studies also you could able to make. Okay, so this is broadly about the concept of the acoustic emission monitoring. Now this is just some of the snapshots. Okay, so to say about thing, basically in case of a pressure vessels and all, okay, pressure vessels or a larger pipes, okay, you could able to ping this, okay, put this across onto an area and you could able to measure. So these are all the AE sensors which are going to be present. Okay, right. So the application point of view. Then we have the third one, which is called as your the oil analysis. So basically the oil analysis, okay, now it is like just I'll rather call it as a blood test, okay, of a human being is correlated well with the oil analysis of the machineries. Okay, as we go for a blood test thing. So here we are going to check the oil samples and we are going to analyze, okay, for what are the variations. Basically, the oil analysis is a technique which involves collecting and testing machine oils, equipment lubricants, or other fluid samples to ascertain the condition of the fluid and the machine. Okay, so whether the oil consists of the samples of the metals, okay, or is it the oil is going to still have the potential of lubrication, or is it the oil is going to consist of acidity or basicity present? All that can be analyzed by using collecting oil samples. Okay, right. So as we know, as machines are going to wear, okay, when the machines are wear, so the overheating is going to occur. Overheating are trend towards failure. Contaminants are deposited in lubricating oil and other operating fluids. Okay. Now, once these contaminants are going to be deposited in lubricating oil, then when you are going to collect the sample of oil, okay, from the machine, by analyzing the content of the oil, you could able to say what are all the metal particles which are going to be present. Okay. Now by analyzing the metal particle, you could able to say where exactly is the wear which has happened. Okay, which part, okay, which component of your mechanical system is actually being eroded or being weared out because of the amount of heat. So understanding that is going to give you more amount of the information, and you can able to interpret the results in a better way. Right. So what are the benefits of oil analysis? So basically, it increases maintenance shafts general awareness about the lubrication related issues. Okay, and it gives a better approach for the maintenance. Okay, so well ahead of the time period, it gives an approach, and it minimizes the unscheduled downtime. So what doesn't want by any individuals is the downtime wherein the machines are not operating. So you could able to reduce this downtime to a maximum level. Okay. Now the minimization of the downtime is possible by using this oil analysis. Okay, and it provides, okay, basically the oil analysis provides access to the levels and types of contamination and wear in the oil. Okay, and as I said, it gives us an indication that it is still fit for use. This is the lubricant is still fit for use, or is it that need to be changed? Okay, as we could able to see in our own automobile, where when we'll just take out that a lengthy pin and just observe, okay, what is the oil level by just touching it. Okay, you could able to say, is it required for you to change the oil or not? Okay, so that is one type of a visual inspection that you could able to do for your vehicle. Okay, similarly, so there are plenty of other options are also going to be present. Okay, right. Then the oil analysis categories are going to be three largely. One is the fluid properties analysis, then contamination analysis, and wear debris analysis. Okay, right. So in case of the fluid properties analysis, basically it says about the status of the oil. Okay, whether it's going to be physical state or it's going to be chemical state of the oil. Okay, you can able to understand this the status of the oil, and you can able to determine is there any a space for me to use that oil for an extended amount of time. That is the remaining useful life. Okay, that is called as your RUL. Okay, you could able to calculate the remaining useful time or useful life, or is it really required for me to change now, or can I wait for some time? Okay. Now this fluid property analysis will give answers to some of the questions which are given here. So it's like that: does the sample match the specified oil identification? Is it the correct oil to use? Are the right additives are active? Okay, additives within the oil are active. Have additives depleted? Okay, has the viscosity shifted from the expected viscosity? What is the oil's RUL? Okay, all these questions, if you could able to write down the answers to that, then you could able to take a proper decision whether to change the oil or whether to continue for some amount of time. Then we have what is called as a contamination analysis. So by detecting the presence of destructive contaminants, okay, and their sources. Okay, so based on the, as I said, based on the contaminants, you could able to understand what type of contaminants are present in the oil. So based on the contaminant, whether it is going to be copper, steel, or whatever it is, cast iron, whatever it is, then you could able to understand from where this has come from. Definitely, you pour the oil into the system. So definitely the oil, the lubricating oil has gone through all the areas of your mechanical system. So right from the beginning component till the end of the component, once you collect, so you will get to know the contaminants. Based on the contaminants, from which portion of your mechanical system this contaminant has been collected, and based on the contaminant, you can understand whether what is the amount of the destruction which has occurred onto the mechanical system. Then wear debris analysis. So this form of analysis is about determining the presence and identification of particles produced as a result of mechanical wear, corrosion, or other machine surface degradation. Okay, now this is another different case of an analysis, right? Then these are the oil analysis tests which are going to be present basically. So oil analysis category and oil analysis test. So fluid properties, basically the basic test that we are going to do is the viscosity testing. Okay, whether your the kinematic viscosity or the dynamic viscosity is just within the limit or not. Then acid base number. Okay, then Ftir. Okay, then the elemental analysis. Then contamination is about particle counting. So it just says about how much of the particle is going to be present in a particular sample of oil. It may be a 10 ml of oil you collected, and in that what is the particle analysis which is present. Then moisture analysis, which takes care about the amount of water content. Okay, so if there is more amount of water content present in your the oil, definitely the effectiveness of that has been reduced. So that you are going to measure by using moisture analysis. Then elemental analysis. Then wear debris, ferrous density, it is ferrography, you are going to be generally say, then Ftir and elemental analysis. Okay, now here the Ftir is common and elemental analysis is common. So just we'll have a look at very briefly about the concept of elemental analysis. Basically, it says about the principle of atomic emission spectroscopy. Okay, it says about atomic emission spectroscopy, which is also going to be called as a wear metal analysis. In this elemental analysis, basically, it detects the concentration of the wear metals, contaminants, or additive elements within the oil. Okay, now based on this concentration of the wear metals, contaminants, and additive elements in the oil sample which has been collected, we are going to make a statement. There are different, I'm not touching upon all that, there are different ISO standards which are going to be available for this elemental analysis. That means Now, if the oil particle count is going to be this much, okay, what is the situation which is present? Okay, now what should be the maximum level of particle count should be present in a particular quantity of oil that you are going to take. Okay, for 10 ml oil, what is the maximum particle count of this particular metal? Okay, so like that, there are plenty of ISO standards which are going to be present. And just for your information, we have a general methods. The commonly used methods are going to be your RDE, that is rotating disc electrode, and inductively coupled plasma. So these are the things which are going to be present, right? Then we have FTIR, that is Fourier transform infrared spectroscopy. So basically, it is works on the principle of your the infrared. So it is mainly used as your infrared light transmitted through a thin lubricant sample. You transfer, you make sure the infrared lights are going to be put across onto a lubricant sample that you have taken. And as we know, in the lubricant sample, you might be having some metals, okay, and all those metals, okay, are going to have a capability to absorb certain amount of the wavelengths. Okay, now based on the wavelengths that are able to pass. Now, as you are going to pass through the infrared rays with the certain amount of wavelengths, okay, now you could able to understand what is the amount of or what type of wavelengths have been observed, okay, within the material. Okay, means let's say if it is going to be a copper, it can absorb this amount of wavelength. If it is going to be a brass, it could able to absorb this amount of the wavelength. Now, the amount of absorption is directly related to the concentration of that particular molecule. That means molecule present in your oil sample. Okay, now then you could able to observe, depending upon the study of the spectroscopy, which are all the wavelengths which have been observed. So based on the wavelength value, then you could able to say what is what type of contaminants or what type of the wear particles, okay, are going to be present within the molecule or within the particular sample. You can able to make a decision. Okay, right. Then the next technique is going to be called as infrared thermography. Okay, which is with thermography or infrared thermography, it is about the temperature. The aspect or the parameter that we are measuring is temperature here. So thermography is nothing but it's a technique of analyzing the thermal characteristics of an object. Okay, so I am interested in measuring the thermal characteristics of an object from its infrared image. Okay, now we have an infrared thermography which makes you to observe the heat energy radiated by the object. That means a very heated member. Okay, you have run the motor for a subsequently larger amount of time. So if you could able to take a picture of that particular motor by using your infrared thermography, you could able to see the image. Okay, the image could able to judge or you could able to judge by observing the image what is the intensity of the temperature which are going to be present. Okay, therefore means you are observing the temperature. You are observe the temperature and you make the decision. Okay, so data analysis is used to identify potential failures or degradation of the equipment parts. Now here, so basically the concept of the heat comes here. Now generally why we go for infrared thermography is it's a non-contact inspection technique, and rapid scanning you can able to make, and data you can able to record in different formats, and the images obtained are going to be more reliable, okay, and more comprehensive, because you are exactly capturing what is exactly happening within the system. Because in case of the previous sections whatever we have discussed, okay, let's say a vibro the accelerometer, you need to place an accelerator at a right spot. Okay, if you missed out placing the accelerometer on the right spot, then the information what you have got may not be reliable information. So the whole reliability of the information is dependent upon where exactly you are going to place the sensors all about. Okay, that is going to be the catch there. Okay, so the whole story revolves around where have you placed the sensor. But here, when you are going to take a picture, you could able to take a picture of a particular item clearly, and it is the observation, clear observation of the temperature is going to be made by using the infrared thermography. Right. Now these are all the observation. Now you can able to observe just a simple physical motor on this side, and the image taken out by using the thermography concept. Okay, and these are going to be the switches. Okay, so which are going to be present. So by using that, we can able to make the decision based on the amount of temperature, because we know the more the temperature, the more amount of the damage has occurred onto the machine. Okay, depending upon the value of the temperature, you could able to make up a decision. Okay, so these are all the thermal imaging cameras which are going to be available. Okay, you could able to get the high resolution thermal imaging cameras, and this is the application of those thermal imaging cameras taken on a electrical switches. So these are the electrical switches which are going to be present. So we are just capturing the temperature characteristics of electrical switches by using a thermal imaging cameras. Okay, so this is with respect to the temperature. Okay, maybe the last one. Okay, right, the ultrasonic testing. So basically, in case of your the ultrasonic testing, so it is again a concept of your the non-destructive testing evaluation. Okay, wherein you are transmitting high frequency sound waves, okay, into a material to find the defects in the material. Now, there is a handheld the device which is going to be present. The inspector is going to use a probe, okay, in order to send the ultrasonic waves into the material. Okay, now lastly, so this is going to be mainly used to measure the leakages. Okay, so leakages in a larger amount of the pipe, or in the pressure vessels, okay, or in the boilers. Okay, you can able to observe, you can able to consider this ultrasonic testing basically. Okay, so now the sound, now whenever you are going to pass on the sound waves, okay, now if there is going to be any defects which are going to be present there, okay, it obstructs the sound waves, right? Okay, it obstructs the sound waves by not passing on. Okay, so now that gives you an idea about there is something which is there, okay, which is which might create a problem on the data switches, because that will hit a defect, the waves will hit a defect and will bounce back. Okay, and indicating there is some anomaly present in the system. Okay, so based on that, based on how it travels, depending on the way of traverse of the high frequency sound waves, you could able to make the decision what is exactly is present. Is some anomalies are present, some defects are going to be present in between, that you can able to observe. So there are three different methods which are going to be there. One is called as the through transmission, because there is something like through transmission. Now basically in through transmission, we have two different transducers which are going to be present. One placed on both on the opposite side of the material. Okay, so basically one transducer, as we know, it creates a sound pulse, and the other transducer is going to receive that particular sound pulse. Okay, now you are sending a sound pulse with certain amount of frequency. Okay, ultrasonic waves, you are sending a certain amount of frequency. On the other side, you are receiving the sound waves. Now between that, now if you could able to receive whatever it has been sent, okay, so it means that in the path, okay, there will not be any of the defect which is going to be present. Okay, depending upon the disruption in the pulse, depending upon the amount of reduction in the pulse the other the receiver is going to made, then we could able to make sense a presence of a defect in between the path. So this is called as a through transmission. The second one is going to be a pulse echo, okay, wherein it's not possible for you to have a transducer at the other side of the material. So it is more sensitive, and it is used to identify the defects by measuring the time it takes the amplitude signal to travel between different points of surfaces in a material. It means that basically you are trying to understand, okay, now what is the level of travel that it has made. Okay, that is depending upon the travel time. Okay, pulse echo. Okay, you are receiving the images. Now how fast you are going to image? If it is very fast, you are going to image, you are going to receive the image. That means the failures are going to be at the surface level. It takes the more amount of time means now you can able to observe where exactly the defect. If it crosses the whole of the material and then come back, the time taken is going to be larger. That means it has traveled all the way. Right. Then we have the last one, which is called as the resonance, which is similar to the pulse echo. Okay, now I'll the 10 minutes. Okay, now where this ultrasonic testing is going to be used. So the basic principle of ultrasonic testing is the use of sound to inspect a material thickness at different points. Okay, so as I said, so it is going to be largely used for an NDT method, and it also can be used to find the corrosion. Okay, if corrosion means the accumulation of a mass, right? So if there is going to be a more mass is going to be present, so that is nothing but a larger, thicker area compared with that of the any other a clear area. So by using that, you can able to observe is there any amount of thickness which is going to be present. That is nothing but a deposition which has been present, right? Now these are some of the snapshots which are going to be used to say about the usage of the ultrasonic testing. So we have ultrasonic detector which is going to be placed here. Okay, so right, and you can able to make the observation on the monitor there, right? Now these are all the things. Then the last one is going to be the remote visual inspection. Now I just started with the visual inspection. Now I just like to end with the remote visual inspection. So when I say remote visual inspection, there we thought that the person's presence is going to be required in order to inspect. But with the advent of the newer technologies which are present, okay, with the presence of your Industry 4.0 concept, now it is possible for me to remotely capture the images which are happening. Okay, so like in a mine industry or like in a fire thing has happened, wherein it is highly not possible for a person to be present there to know the things which is happening. So I can have the RVI tool, remote visual inspection tools are going to be present, which could able to collect the data remotely without the presence of a person. Okay, so in-person requirement is not going to be present. Okay, right? Inspectors usually want to use RVI instead of conducting a visual inspection in person because of the area that needs to be inspected is dangerous. Okay, now these are the something which are going to be present. Now one is going to be your the mining area, okay, wherein I can have a different a good resolution drones can be present. So the drones could able to be sent across to the mining area so that we can able to take the picture, and the picture representation could be sent back to the not sent back. You can able directly observe remotely at your office, and you can able to make the decision. Some fire hazard has occurred. Okay, so there itself you can able to make the data collection. So this is the advances which has been present in case of the diagnostic maintenance, right? So basically till this time what we have covered is the basic techniques. Rather, I am going to say the very basic techniques which are present in the diagnostic maintenance, right from the visual inspection, wherein the observation you have made, and then the vibration monitoring. Okay, and then you could able to understood about the acoustic emission monitoring, then the oil analysis, then our the ultrasonic testing. Okay, and then the RVA, the remote visual inspection. Now with this, all these different sections what we have gone through about the diagnostic maintenance. Now where we stand basically. So when we say about the diagnostic maintenance, okay, basically as it was pointed out in the very beginning of the inauguration, so prevention is better than cure. Now basically the diagnostic maintenance is one of the very important technology which needs to be done in a clear, concise way, so that there you can able to cut down the breakdown to a very larger level. Okay, the idea is to have the zero downtime at any of the period of operation. Now this diagnostic maintenance, okay, with the time elapsed also has gained a good momentum with respect to the Industry 4.0. So as you already come across, okay, as the learned members, as you already know, we have what is called as an Industry 4.0, which says about the fourth revolution of the industry, wherein we largely talk about what are called as the smart sensors. Okay, wherein so I will not be there, you will not be there to observe. So basically you have a well equipped sensors which are going to be present, okay, which are going to be used to take up the data. So the impact of Industry 4.0 is enormous on the diagnostic maintenance, so as to make the diagnostic maintenance a foolproof one. Okay, rather I will say diagnostic maintenance should be completely foolproof, so that there should not be any miss out of any happening within the machineries that should not be missed. Everything should be captured. Okay, and the another important thing is the real-time condition monitoring. Okay, so this is what is happening. You are taking the data and you are not analyzing the data after a certain amount of time. Okay, so it is the real-time situation you are understanding and you are taking a decision. Okay, as and when it is happening, you could able to clearly make up the analysis. Now here is where the analysis softwares are going to come into the handy. Okay, so with the invent of your industry 4.0, a large amount of analytic tools which are going to be pumped into the industry, wherein the data analysis, as you are already come across, which is a field which is picking up very heavily now. So the data analysis is going to be plays a key role in making a correct decision, because it is very, very important, making a reliable, correct decision based on the data available. I have a data, but how do I analyze the data in an effective manner? That is what matters. Okay, so my inspector, my smart sensor has done a very fantastic job, but my analysis tool, okay, is not so well enough to take the data, to analyze that, to process the data, and to give a clear picture. Okay, so that can be avoided. So real-time condition monitoring is going to happen, and flexible evaluation and analysis options. Okay, then targeted notification of experts, that is very important. Targeted notification of experts means, so as you are going to do the real-time condition monitoring, so in the real time as happening at this time, so this is the situation. Okay, then you can definitely pass that information onto the targeted expert. Targeted experts are the one who are present nearby the machine. Okay, so in the next minute there might be a chance of failure, so you just notify them, okay, based on the data what you are doing, that to a real-time data. So you just notify them immediately through a mail or through a notification, okay, that there is going to be a definite failure which is going to occur on this machine by another 2 minutes or 3 minutes. Okay, so that is going to give a clarity for the expert to make the decision. And then the smart sensors. Okay, so presence of smart sensor, highly resolution sensor will pave the larger way for making this diagnostic maintenance as effective as possible. Okay, and monitoring and industrial analytic tools. Okay, so this is as I said, the presence of the various monitoring tools are going to be there. So the industrial Internet of Things, IIoT, is picking up, which is a very a great feature of your industry 4.0. Through IIoT concept, you could able to have a better approach towards the development of the industrial analytical tools with the concept of the data analysis. Okay, so these are the advances in the diagnostic maintenance, which we could able to observe in the near future, and which is happening. Okay, right. So with this, I'll just like to put the concluding remarks on this. So basically, we have I have made my attempt to give a broad perspective towards the concept of the diagnostic maintenance. What is diagnostic maintenance, why it is important, and the broad overview of the various different techniques of the diagnostic maintenance, from our the visual inspection to vibration to acoustic emission to oil analysis, ultrasonic, and all that. And basically this diagnostic maintenance, the theme, okay, it appears to be more realistic compared to other maintenance techniques. Okay, because other maintenance techniques will have their own disadvantages, because in breakdown maintenance you are checking only after everything is over, and in preventive maintenance you very oftenly take the data, by which there might be a more amount of investment is going to be there. So diagnostic maintenance, it's like continuously analyzing the data, and this is based on the fact that 99% of the equipment failures are preceded by certain signs, conditions, or indications that such failure was going to occur. That means the essence of the statement is that any failure will not going to occur just like that. Okay, so it shows some information, it gives certain signature, it gives certain indications. Okay, now what matters, what is very important for us is to pick those signatures. Somebody is telling something is going to happen. Okay, so if we could not able to pick that signature, pick that indicators, then we are not giving ears to those point, and subsequently the machine will definitely going to fail. It has told you there is something is going to happen, and that is what is very important, that you need to pick up. That picking up is going to be, can be effectively done by what is called as your diagnostic maintenance tool. Okay, so diagnostic maintenance techniques were discussed with emphasis on how these techniques work towards maintenance decision making, and in general I conclude that each of the diagnostic techniques what we have discussed have their own advantages, disadvantages, principles of operation, and as per the requirement of the necessary tools which are going to be there, and we can able to exploit those tools to the maximum level, and we could make sure that the diagnostic maintenance are going to be taken care, by which the very aspect of the maintenance is the availability should be made 100%, and the 0% of the downtime. Okay, so if you could able to make 100% availability of the machine, so which implies that there is no time that I have lost because of the last time, then we have made the diagnostic maintenance very effective and fruitful and completeness. Okay, so with this I am concluding this the presentation. So thank you for your the patient's hearing. Okay, so if you got any queries, I'm happy to answer. So thank you for your patience hearing throughout the session.
Thank you, sir, for sharing your valuable knowledge on the topic, Introduction to Diagnostic Maintenance. Now I request the participants to clear their queries. I request the participants to ask queries.
Yeah, please say.
Myself, J.S. from Kolab.
Hello.
I would like to ask one question related conditioning one.
Hello, sir, you're not
My
clear,
first question
sir.
is related.
Sir, I request you
I'm
to
audible,
put
sir?
your query in the chat box. Sir, I request, or
Yeah, please tell me, sir. Tell me, sir. Tell me.
Wait, sir.
Hello, sir. Am I audible,
Yeah,
sir?
tell me. Yeah, tell me, sir. Please.
In the conditioning monitoring of oil analysis, which techniques are more preferable? Means offline oil analysis or online oil analysis technique, which is most effective and most preferable technique for conditioning monitoring of oil analysis? This is my first question. And second question related with, can you tell us something about ferrographic analysis?
Yeah. Okay, right. So briefly, so with respect to your oil analysis, so basically what this oil analysis is going to be done is you collect the oil samples, right? You collect the oil samples and make the decision. So as you are going to collect the oil analysis, it matters that generally it is going to be like an offline analysis only, because you take the oil analysis, you do the testing at a particular point, and then you take a decision. Okay, so that is going to be about the oil analysis. Then about the ferrography study, basically the ferrography study is going to say about the amount of the iron content which is going to be present. So what we'll have is basically in case of ferrographic analysis, so we'll be having a ferrographic machines which are going to be there. So wherein I'm going to study about what are the oil. I'm going to take a sample, basically take some 10 ml sample or whatever it is, and taking those 10 ml sample, I will pass on the waves to that and take the information regarding the wavelengths. Now the content which are going to be present, let's say if it is going to be iron, if it is going to be brass, it picks up certain amount of the frequencies. So which frequency it has picked up or which frequency it has observed. So based on the absorption of the frequency or the wavelength, we are going to say what exactly is present. That is going to be generally considered as the ferrography technique.
Thank you, sir. Thank you. Thank you very much.
any other queries?
Yeah, so one more question is, how is the machine problem severity rated? So basically, Mr. Dr. Ranjit, so here for the machine problem severity to be rated, so we have what is called as a ISO specification for a particular analysis. As I said, just one I just want to make, if it is going to be a vibration analysis, we have something called as ISO 10816. Okay, so I'll repeat. So we have ISO 10816. So based on this, what this ISO 10816 says is that depending upon the machine, okay, what type of rating of the machine, what the rating is in sense, the wattage of the machine. So we have small machine, medium machine, and higher level machine. So there are 4 categories which are going to be present. So out of these four categories, he has given very clearly that what is the acceptable vibration level to be present in each of the categories. Let me say that vibration velocity, if it is going to be 3.33 meter per second, where that is going to stand. Okay, so whether it is going to be acceptable or is there any problem which are going to come like that. So this is one such example that I have given for vibration monitoring. Like that, for the various different the monitoring techniques, we have a clear-cut standards developed by the International Standardization Organization for International Standardization, ISO. So for each of the cases, let's say for oil analysis also, so if the pp, we say it as ppm, parts per million. Okay, so if in the particular oil that you have taken, if the content of the iron is going to be this ppm, is it going to be a problem or is it acceptable? Okay, all is going to have a very clear indication in the ISO charts. Okay, it's all based on the ISO charts. On that we are going to take up the decision. Okay, otherwise without having a barrier, it is not possible for us to take the decision.
Any other queries?
From where we can get the threshold value of different oil properties?
Sir, it's available in the, I'm not exactly not remembering the ISO number, okay, but it's available in an ISO chart actually.
Thank you, sir. Thank you.
Any other queries? Sir, hope that the queries are over.
Yeah, okay. No, if it is over, okay. So thank you very much. I like to thank Dr. Guru Pawan and team, okay, for giving me an opportunity. Thanks to my alma mater for giving me an opportunity to share some of the thoughts that I was having with respect to the diagnostic maintenance. So thank you all, dear participants. Have a nice presentation, follow up through in this 5 days of session. Thank you all. Have a nice day. Have a safe day. Thank you. Thank you.
Thank you, sir.
Thank
On
you.
behalf of Mechanical Engineering Department, PSE Mandia, we thank you for your contribution.
Thank you.
Thank you, sir.
Thank you. Okay. Thank you. I am just signing off now.
Thank you, sir. Yes,
Thank you.
You may.